Hello students, this lecture is for B.Sc second year class and paper is group theory 7th paper, semester 3rd and lecture is 13th. We are going to discuss what is meant by equivalence classes. Definition is equivalence classes or equivalence set. What is meant by equivalence class or what is meant by equivalence set? I have already written this definition. You can write down it. Pausing video. You can write this is in your notebook. Now I am going to discuss this. Let A be a non-empty set. Look it. A be a non-empty set and R be a relation. In E, we defined one relation R on the set A. A be the any non-empty set. Further, A be any arbitrary element of A. It is element. It is, this A is not alphabet. It is element. So this A be any arbitrary element of A and the element X belongs to A, then other some element X belongs to A satisfying X or A. That means that relation satisfied with that arbitrary A constitute a set A alpha and form the new set that is A alpha, A small a of A called an equivalence class of A. This is called equivalence class. It forms the class A suffix A and this class of A, this class A small a or the suffix A of the A called an equivalence class of the A with respect to R symbolically we can write it A small a, that is equivalence class, or equivalence class to A, or A closure, that is equivalence class to A. So in equivalence class to A there are X elements such that X also belongs to A and X related to E. X related to E that belonging to the relation R. That belong to relation R. So X R A. There is a relation X R A. So remember this thing. So such a type of classes are called equivalence classes or the equivalence class of A. What is the equivalence class of small a? So equivalence class of the small a is denoted by this symbol also or is denoted by this symbol also, and which element contain in set A closure are X such that X belongs to the A and X A are related to each other. We discuss one example. What is meant by the equivalence classes and its example? So equivalence classes in the set I. Now we take one set, that is set of integer I. We are taking this for our study. Of all integer with respect to equivalence relation, and one relation is congruence modulo 5 relation is there. So in our definition, set A is, we consider here set of integer I, and we define one relation that is congruence modulo 5. So here we observe that the integer congruent to 0 modulo 5. So congruence, in congruence relation 0 modulo 5 means take those elements having or leaving a remainder 0 after dividing by 5. So after dividing by 5, we get the remainder 0 in which I0 class. And what is which element include in the I0 class? Multiple of 5. So 0, 5, 10, minus 5, minus 10, all these numbers include in the I0. So I0 is equivalence class. With respect to relation, congruence modulo 5. So all are the multiple of 5. The integer congruent to 1 modulo 5 we discuss next step. 1 modulo 5 means remainder is 1 after dividing by 5. Then we get I1. Then we get I1 set. And this I1 set include all these numbers leaving remainder 1 when divided by 5. Dividing by 5 to 1, remainder 1. Dividing by 6 to dividing by 5 to 6, remainder is 1. Dividing by 5 to minus 4, remainder is 1. Like that. Now similarly I2 means 2 modulo 5. 2 modulo 5. After dividing by 5, here we choose those integers. Leave remainder 2 when divided by 5. Here we take those integers, leaving remainder 3 after dividing by 5. Here we take those integers having remainder 4 when divided by 5. Now we cannot take I5 because after multiplying by 5 it is not possible to remain remainder 5. So it is enough. So we get 5 classes: I0, I1, I2, I3, I4. We get these 5 classes, and all these 5 classes are equivalence classes of congruence modulo 5. Congruence modulo 5. So here we get so in example set I with the set of integer, all set of integer. This is the set of integer. And our relation is congruence modulo 5. Congruence modulo 5. So with respect to congruence modulo 5, we get some equivalence classes, that is I0. So in I0, only those elements take who leave the remainder 0 after dividing by 5. So we get the multiple of 5 elements. And so on. Then we get I1. Then we get I2. So in I1 there are some elements: -9, -8, -3, 2, 7, -4, after that 1, 6, 11. In I2 -8, -3, 2, 7, 12. In I3 -7, -2, 3, 8, 13, like this. In I4 minus 6, minus 1, 4, 9, 14, like. So student, these are classes I0, I1, I2, I3, I4 are equivalence classes with respect to the relation congruence modulo 5. So these classes have the following properties. These classes have some properties. Now first we observe that you see very carefully and try to find which things you have to find. So I found that this set I, that means our original set of integer on which we define this relation. This set I is nothing but the union of I0, union I1, union I2, union I3, union I4. Any doubt? This set I, that means the set of integer, is the union of all equivalence classes of the congruence modulo 5. Then second, I found that integer in each class have relation of congruence modulo 5 with one another. Yes, all these are integer congruence modulo 5 with one another, satisfy the relation. Third point, integer in different classes do not have relation of congruence modulo 5 with one another. In one classes satisfy integer congruence modulo to one another, but different classes do not have a relation of congruence modulo 5. And fourth point is the classes are mutually disjoint. If we take the intersection of all, these all, then we get empty set. No common element is there in I0, I1, I2, I3, I4. If we take intersection of all of them, then we found that there is no common element. So therefore intersection is empty and union is our original set, that is the I. And element belong to the same class has a congruence modulo relation 5 with respect to each other, but element of one set to element of other set does not satisfy the relation of congruence modulo 5 to each other. Now student, in next lecture we discuss some more properties of the equivalence classes. I think you understand what is meant by equivalence classes or equivalence set. So student, in next lecture we will discuss on properties of equivalence classes, and after that we will study very interesting concept, that is group. Okay, now today we stop it here. Thank you so much.